So the talk today will be about on-demand environment, also called Sandbox environment. It's a concept that's been around for a few years. I mean, most people try to do it. Most people want to do it. There's a lot of gain. What I'll try to talk about today is not just the technical side, but try to explain what are the benefits for developers and for QA and for actually even product manager also, so they can actually be able to have a quick cycle in agile development between the developer, the tester, and the product itself, without any impact or delays between all those phases. I'll start by explaining a little bit about what is an on-demand environment. The base idea between those environments is that they're completely ephemeral. You want to be able to recreate them, destroy them, without even, I mean, you did a mistake, you destroy your old environment, well, you don't care, you just recreate your one and then you start over. So I was talking with someone earlier and we were like, onboarding also, which is a side of it that I didn't really think about, is that you can give someone the whole stack and create it for him and give him complete access to it, to break it, to play with it, just so he can actually try to understand how the different pieces work together. So in my microservice architecture, you have a lot of moving pieces, and it kind of becomes hard to follow it up. So the idea is that play with it, break it, and if you break it too far, you destroy it, you start over again, and you figure out how you broke it and why you broke it that way. Short lifespan. The idea also with Amazon has the same principle. The idea between the EC2 instances is something that is short-lived. You start the instance, you run it, next version, you destroy the instance, and you recreate it. So you have a lot less to think about storage, lifecycle, security updates, things like that. So the shorter lifespan of your stack or your services, the less maintenance you'll have to do with it, which is where a good gain can be had on that part. 100% reproducible. Like I said, I create one, the guy next to me wants to create another sandbox environment, they'll end up exactly the same because everything is automated. There's not, you don't have someone actually does the work and actually inputs command for you to create the environment. One of the past jobs I had was for a bank, and we had an AIX server running 99 instances of a website for all the different teams. There was maybe 50, 70 different teams working on the same website. And there was actually 99 users on that machine, and each user had their own installation of WebLogic with different script, and everything was run with a bash script and manual commands and property files and all of that. And I mean, that was like the beginning of what is automated creation, but you look at that and you request an environment and you have to wait a week for the environment to be cleaned up for your next project. So at that point you have a lot of wait time, a lot of context switching, and a lot of cost associated to those environments, which shouldn't be. I mean, it should be a question of a few minutes to create those environments. The other interesting part with on-demand environment is that you can choose your own ownership. It could be a single person. The person is trying a proof of concept or something. It could be a team working on the same project and each pushing their own microservice version. Or it could be a long project of a few months where you have different teams working on different components and all coming together in a single staging environment. So even if the stack is not as short-lived, you can still have the same gain of being able to destroy it, recreate it, repush the right version of each component, and have the same 100% reproducible environment for your project. Another good feature that I really like having into those Maybe it's a little bit my side of wanting to control everything, maybe, but I want people to have access to all of it. So the stack that you create, you can break it all you want. You can delete the services, you can add services to it. Even if those services weren't designed at the beginning to be part of those stacks, the user needs to be able to have that complete sandbox. The idea behind that is that locally you want to try running your different services. You want to add a new one, then normally when you're local, you just start it, you start your 6, 7, 8, 30 services locally, everything's slowed down, and then you're stuck with that very slow machine that you can't do much. The idea is to be able to reproduce that same flexibility, but on a centralized server where you can interact with other people. And the full control gives you some kind of root access to your stack. So you're not blocked waiting, oh, I need a new schema on my database. Well, okay, I'll open a ticket to the DevOps teams or the DBA, and then you have to wait that they create your new schemas for your new service. In this situation, you have access to it. You do whatever you want with your database schema, and you can delete it, you can truncate it, you have full control. And probably the most important one, it needs to be dumb easy. I mean, it needs to be as simple as just raising a hand and saying, I want a new environment. And then the environment is there. So it needs to be, you don't need to have like 2 weeks training to be able to create those environments, which is used to be the case in most environments. I remember onboarding for different companies, and then you have that nice wiki page with like 50 different steps to, okay, you need to install brew, and then you need to install this, and then you need to install that, and then a week later the developer is actually able to start your service, and then it's a lot of cost, a lot of frustration for everyone. So the idea is to get up and running as quickly as possible without any impact on anyone else. Goalless gains are associated to that. Talked a little bit about it in the previous slide. Is one of the most important one is throughput. And the throughput can be seen on multiple factors. It can be the fact that you have a bug that you need to reproduce, and you need the environment with the right component to reproduce it. So you don't have to actually wait about anyone to be able to do it. So you create your stack, you push the right version of whatever service you need to push, and then you should be able to reproduce it. For sure, there's still the difficulty of finding those bugs, but at least you have all the tools you need to be able to achieve that. Throughput can be seen also on the side of development, performance testing. If you have your own service and your own stack and you want to test whatever feature on it to get a gain of performance, then you have the control of it and you can do whatever you want. Normalization. Local development, everyone knows, is kind of flawed. It works. It's not perfect. There's always a lot of, the best example is everyone has a local config. You're running your service, and then your service has a completely different kind of encryption or configuration, which different driver to access the database because you're running, I don't know, maybe an in-memory database locally or things like that. So what you want is to be able to do your development, but at the same time has something that feels like you're in staging or in pre-production or even production at one point. So when you're able to achieve that, then it's much easier to detect where the problem might be, or actually be able to not create problems when you push new feature to staging onto production. So the sooner, and one of the base idea beyond that is that the sooner you detect an anomaly, a problem, the less it's going to cost to fix it. So the later in the test cycle that you find a bug, the more expensive it becomes because a lot of people are involved. You need to transfer the ownership of that problems and things like that. So having access to an environment that as close as production gives you that power to be able to not have any difference between the different environments. Independence, I talked a lot about it. I mean, it's being able to not have to wait about anyone. Everyone has been doing context switching. Everyone knows that context switching kills productivity. So if you're able to be totally independent, then it's just a question of being able to know how to do something. So the on-demand environment gives you access to doing pretty much anything to it. Now the next step that you need is simply have either good documentation or good training about how to achieve what you're trying to do with those environments. Ownership, responsibilization, kind of a little bit the same. It's your stack. You should be responsible for what you do on it. When you're pushing a new feature, then you actually are empowered with that on-demand environment to be able to know what you're trying to do and what you shouldn't do. So you'll see much quicker the impact of your changes. Teamwork. Sandbox environments are great for single developers, but they're also good for projects, like I stated earlier. You can share in an agile process, the principle is there. You talk with your project manager, he asks you for a feature, you create that feature, and in a normal cycle of testing, then you push your pull request, and then, I don't know, maybe 2 weeks later, when it gets merged into a staging environment, then your product manager can actually look at it and then tell you, oh no, there's that feature or that logic that's not right. With an environment that is specific to you or for an actual feature, you're going to be able to actually do your change, push it to the environment, and have your product manager or the one assigned to that project be able to watch it like within a few hours or a few minutes. Cost saving. I did a quick math with a stack that we're running. Let's say we have about 30 microservices, mostly Spring Boot, the front end is Nginx under Angular or React. Let's say you need 16 gig of memory to run your stack, which is, for a Spring application, pretty much what you need. Very hungry application with Java, everyone knows that. We use Kubernetes, which I'll talk a bit after. The idea is that, let's say you have 16 gig per stack, the cost per year is about $35,000 of servers. So at that point, let's say you have what the average salary in San Francisco for developer is like, let's say rounded up to 100K. So you need actually 1% improvement in productivity to actually pay off your old cluster of your on-demand. So at that point, it kind of, when you're trying to say, oh, I want to develop on-demand, it's going to cost, I don't know, let's say $35,000. I need, I don't know, a few weeks to develop it. And then the guy says, yeah, but we don't want to pay for it or something. But your ROI is going to be paid in like a few weeks at this point. So the idea is there's that side of it that is kind of a nice leverage to actually play with cool technology and be able to make your developer and your QA very happy to be able to have access to those kind of features. So I'll explain a little bit the workflow that we put in place. You have your nice little hacker developer right there. It could be simply a QA with a hoodie. He creates a feature. Let's say we're using Git in this situation. We use Jenkins for our continuous integration. I mean, Circle CI, Travis, they would all come down to the same principle. And then you have your Docker registry. So the idea behind it is that everything in this context is leveraging containers, is leveraging Docker for, I'll cover the technical part of the Docker later and the Kubernetes. We use different input control for our on-demand controller. We have Slackbot. That was the first input controller for it. It's kind of easy to code. It's fast to actually test it. I personally sucks at UI, so it was much faster for me to do text-based than actually doing colors and trying to align tables and things like that. So for me, it was much bigger. And we have our on-demand process. So we call it on-demand, very original name. But the idea is that that's the heart of the whole automation process. Could be coded in any language. We use Golang in this case. We use, with Docker, with Kubernetes, the Golang library SDKs are very interesting. We use a lot of the watch services coming with the SDK and things like that. And then you have your Kubernetes cluster. So, your developer does a PR. So he's working on feature to, I don't know, add a new input field or new validation in maybe a UI. So your developer works locally, codes things, kind of works, but he want to test it globally, make sure there's no impact to anything. So he puts it he does his git push, git triggers the continuous integration. So Jenkins gets the hook, says, oh, we have this new module, there's a new PR open, okay, so we start building it. Runs the test, compiles everything. Once everything goes right on that part, generates his Docker container. From there, you're pushing it to the Docker registry, and then you have everything you need to actually start using that services. You could be running it locally. You could have built Docker container locally, tested it like you would do with a normal environment. But at this point, what you're doing once you have a confirmation that your Docker container is in the registry, is that you call your nice Slack bot and say, oh, by the way, create me a new environment and deploy my PR to it. So the Slack bot receives the message, acknowledge the message, and then sends it to the automation server. The automation server will do a couple of validation, make sure the user has access to it, make sure the cluster has enough resources to create a new stack, and also make sure that the PR is requesting to deploy actually exists. So it's going to poke the Docker, or in our case, Artifactory, and then says, oh, does that actual image exist? If so, then it starts creating. There's multiple ways of pushing it. We use a custom templating engine. I'll show a little bit of it in the demo part. You could use something like Elm. You could use completely custom. But one of the things that we wanted is to be able to have a very simple templating engine, and a developer could add a new service to that template within a few minutes. So we didn't want the developer to have to code anything to add a new service. We didn't want him to have to request help from another team to actually integrate new services. So everything is very normalized so that each service are as close as possible to each other. On the Kubernetes side, we use Namespace Isolation and RBAC. For those that are not too familiar with it, the namespacing of Kubernetes is kind of well done. You have a service discovery within the same namespace, that's automatic. And you also, with RBAC, you're also able to completely create an entity, a user access to that specific namespace. So what happens at this point is that we create the namespace, we create a user that has only access to that namespace, and then we give the user back through the Slack bot, here's your access token, and you can do whatever you want with that environment after that. So the user can delete the stack and do whatever it wants, but it'll never be able to impact anyone else on the same cluster. So it really isolates your namespace and your access level to that specific namespace. At the layer of the templating engine, the idea was to try and get something up and running for the on-demand. Our stack right now is not on Kubernetes. The idea was to use the on-demand environment to slowly show how we could implement and use Kubernetes in production and in staging in different environments. We also use the on-demand the server to create a continuous delivery system for our master branches. So every time something is pushed on Jenkins, Kubernetes will fetch a container from Docker. But what we do also during the triggers of Jenkins is that once something is merged on master, after being validated, reviews, QA tested, everything, then we have a webhook from Jenkins to our on-demand environment that tells it to update our master stack. So we always have a master stack that's exactly the same as our master branch. So every time something is deployed, pushed to master, then it's automatically deployed to our on-demand master stack. So we have different kind of type of namespace on the Kubernetes cluster. We have the on-demand one, which is owned by a user. And we also have administrative or QA permanent stack. So the idea is to be able to create, at one point, we could have one cluster with 50 developers stack, and we could have also 8 QA stack for whatever regression testing and all of that. And everything could be automatically deployed with webhook and things like that. I will, the list of features that we implemented up to now is pretty limited. I mean, there's a lot of work still to be done on our stack, but the idea is that everything is, with the predefined services release, is that you have a master stack and you want to be able to manage which version. Right now, when we deploy a version to Kubernetes or to whatever production, we kind of release everything with a normalized versioning. So when we create our master stack or our environment, we say deploy the latest release. At one point, when you have multiple microservices that have a different versioning and life cycles, you'll need to be able to manage what version is actually in production, what version is actually in staging. So when you want to create your stack, you need to have something easy for the developer to know what he's deploying. So it's easy to say deploy latest. So because of the way Docker works, when you push a version, you push to master, you also push the version, but you push it also as latest, let's say. But let's say you have in production, you have 5 services, and each service has a different version that's different with your development environment. If you want to create a stack to be able to debug, to reproduce production, then you need to have some kind of versioning, a centralized way of versioning your version to know your program to know how to deploy them together. So that's something we're still in the work of implementing. There's also some feature to enable, disable services. By default, there's always, in our situation, we have services that are not needed for the regular workflow. We have batches, we have different things like that. So the idea is that when you create your stack, you're able to ask which service will be enabled by default. So if for whatever reason I'm working on a very specific module that's not enabled by default, I just create my stack and I just ask it to enable that specific service after that. It's a simple question with Kubernetes of doing a scaling from 0 to 1 or 1 to 0 to disable your modules. Namespace isolation, as I explained. kubectl access. For those that played with Kubernetes, kubectl is like the new bash of Kubernetes. It can do pretty much anything. There's a lot of things that you want to make it easy to do through a chatbot or through a UI, but at one point there's always edge cases that you can't cover. So the idea here is to try and do the happy path and do what's the rule of 80-20. So try not to overdo it on that side if you're implementing your own on-demand. The idea here is that you give the developer kubectl access with the keys that you generated on his namespace, and at this point, the user can actually do anything it wants. Your UI or your chatbot doesn't allow you to create a new service. Well, kubectl will allow you to do it. So you don't have to code every single use case in your automation feature if it's not something that everyone's going to use. We use log aggregation, very simple Elk stack. Since we're deployed on AWS, we use the built-in Elasticsearch cluster. We also even implemented in the chatbot, like and in the UI, a quick button next to each of your service that I'll show later to actually go see directly the logs of that specific service. So we give all the tools for the developer either through kubectl or through Cabana to actually have access to everything it needs to debug its service. Telepresence. Anyone know that tool? Anyone played with it? It's a really nifty tool. What it allows you to do, everything runs on the kube cluster. So let's say you have a problem and you're deploying everything into that cluster, but you kind of want to do debug. Normally, you would do locally debug, and then you start your process in debug mode, and then you attach your IDE to it, and you start debugging line by line, and then everything. But since you're on Kubernetes, you're kind of losing that feature, so you can't really you could remotely debug. But with what telepresence do is that it kind of creates a virtual service locally that runs as if it was in the cluster. So the idea is that you start your local process locally. Let's say you're modifying service, one of the service. You start it locally. You tell telepresence that process, you want that process to actually run as if it was one of the pod in the Kubernetes cluster. So what it does is that it creates a virtual VPN between the actual pod and your local service. And it transfers everything that the service does as if it was running in the Kubernetes cluster. So you do DNS resolution, the DNS resolution will run as if it was the pod doing the resolution. So everything that you do act as if the local process was actually running in the cluster. So it kind of gives you the same feature of debugging locally, but your process is actually running in the namespace in Kubernetes, having access to whatever DNS or whatever service discovery that you have on that stack. It's DataWire that coded that software. Really cool tool. It's really worth playing with it. There's a lot of little feature to it, but one of the main downfall of it is that it can actually only run one process at a time locally because of the way that the VPN actually works locally. So I'll show a little bit quick demo of our on-demand. The way that the service is, the way that I created that demo is that I'm running two services. It's two front-end services, simplifying a little bit the logic behind it. We're gonna ask, not this one. So I have my server at the on-demand process that I was talking earlier. So it's a small Go, well, getting not that small with time, but like any program.
Can you make it bigger?
Yeah. So a quick small program. What it does is gonna start. It's gonna connect to the Kubernetes cluster. It's gonna start a couple of watch. It's going to start watching for new namespace, it's going to watch for new pods, it's going to watch for a lot of different information from the Kubernetes cluster so that it knows the state of the cluster at every single point in time. We have a UI that starts into it, we have a webhook, it's GraphQL endpoints, and also there's the Slackbot integration that's all inside the same program. So it's really a single program that does all of it. The idea behind it is to be able to control access to it the number of stack, controller the creation of stack to make sure that we don't create too many stacks and crash the cluster. So I also have two namespaces that right now show that there's no container because I didn't create everything's running on Minikube locally. So it's really a small local version of the cluster we're running. There's nothing shown. If I look at the namespace, so like I was talking, the cluster is pretty much empty. The only namespace that we have is a monitoring namespace that I created, which contained Prometheus and Grafana simply to monitor the actual resource usage of the cluster. So at that point, what we do is that we connect to our Slack bot, which is online. So let's zoom that. So the chatbot is very simple. You ask for help, it gives you help very nicely. Gives you the list of all the commands. We have a couple of features that we put in place. Lists all my pods, create me a new stack, redeploy a service, restart all the service because something's broken, or delete the stack. So let's say I want to create a new stack, and I want the latest release. So I ask the bot to create me a stack with the latest, greatest of our software. So what it does, it says, okay, creating stack. Okay, it's done. So at that point, we look at the namespace, and now we have a new namespace, which is the name of my user on Slack. So everything is bound to your, in this case, the username of your Slack handle. At the server level, what it did is that it received his request, and then what it did is it called the templating engine, generated the template based on the input, which the input was very simple. Remember, I said it needs to be really simple, so we just gave it the version I want, which is latest. So it created the YAML, and then it pushed the whole YAML to the server. So what it did is it created the role, the binding, the config for each service. So we have two Hello World service, and then it created two ingress to be able to communicate with the service. This one. So at this point, I can say, okay, well, tell me what's the state of my pods. So I ask the Slack bot, say, okay, tell me what's going on. So instead of using kubectl, which I could very well do because I have full access to the stack, then we still implemented the same thing at the Slack bot level. So it's telling me that I have two services, both the containers, there's only one container per pods, everything's running, no restart, and the age, and which version it's actually running. So we kind of simplified the view to show really a quick view of the services. So at this point, what we have is that we use an Ingress Controller called Traffic. Really simple. What it does is that when you define your Kubernetes service, you define it an ingress based on FQDN. So you tell him which domain name is associated with your service, and it creates an automatic ingress based on it. So that's the UI that tells me that I have Hello World dash JP Bélanger, which is the name of my stack, .minikube. So anytime a request is going to come in, which has that domain name in the URL, is going to forward it to that specific service. So if I load Hello World JP Bélanger, then I get my nice Nginx container with a very simple index.html that returns those values. So I have two of those. So I have Hello World 2 and I have Hello World 1. Let me zoom in a little bit more. So it's really two different containers, two different code. And if I show quickly at the template level, it's that easy. So we have the default, in this case, Spring Boot, which we don't have in this demo, so I could simply remove it. But we have an Nginx, which we give it a memory value of 50 megs per containers. And then we define our application. So we have an application called LOL1, which is of the type Nginx, which is using that container name and that version. And then we define a title to it. So what I did for the presentation is that I pushed two environment variables to the container to be able to update it. So the idea here is that the templating is also dynamic. So if there's a new change that we need to apply to all the stack and I want to be able to apply it, then I could just come and change the template here, tell the on-demand service that the template changed, and it'll be able to actually reload it and apply that value. So at this point, what I could do with the bot is that, okay, now is the latest version, but I did a PR. So I want to redeploy a service, which is Hello World 1. And I want, I think it's PR1. So I tell the bot that, okay, I just did a PR. Everything has been pre-built for the demo. But the idea is that I tell him, okay, I want you to redeploy the container LOL1, and I want you to deploy the PR1. So what it does is that if I look, I re-ask him to show me the pods, is that it's currently stopping the Hello World container, and then it's actually started to run a new version, which is my new PR that I've deployed. So at this point, I have my code that's running on the cluster. And if I reload Hello World 1, then now I have a different version of the container that's running. It gives you access to the kubectl command. We kind of implemented a very simple command that says, give me the bash or the shell value that I need to paste in my shell to create the kubectl access to it. So at this point, I'll be able to use kubectl on anything. So at that point, I'd be able to do kubectl, and I ask for my namespace. And I have the same value that was returned by the chatbot. So the chatbot was really a quick way of getting most of the feature out without having the user actually know the command of the kubectl. Then after that, we decided, well, let's do a nice cute UI on top of it. So we have that nice, so we have a UI that shows the list of all the running stacks. So if you're a single user, then you'll have your stack that you can click, and the UI will show you exactly the same view as the Slack bot showed you, which is the list of the running containers, things like that. You can actually get the kubectl command that I was showing you, and you could redeploy, you could restart all services, or completely destroy your stack. So one of the things also is that you can see which is the ingress. So when we were talking about the Ingress Controller to access my service, then the UI will also give you the URL for your services. So if it's a UI, you'll be able to access it and simply by clicking. We also implemented the give me the last 100 line of logs into the UI. So it's simply calling the cluster and getting the logs from the service itself. We do have the Cabana integration, which for this demo doesn't work because everything's running local. But the idea is that it generates a URL with all the filter predefined into it to actually list only the logs of your service, of your stack. So that way you don't have to go to the UI and then filter all the logs of the 50 or 60 or 100 different stack of people running on that cluster. Another feature that we put in place is edit config map. You have all the configuration of your Nginx. Oops. Edit config map. So at this point, I'll zoom in a little bit. We define in Kubernetes the config map is the equivalent of your application properties. It can be mounted as a file. It can be sent as an environment variable. So in this case, what I did just for the demo purpose is that I created an environment file properties that when the Docker container starts, actually use those to replace a variable inside the index.html. So in this case, let's say it was a property saying how many threads your service is running. Then at this point, I could simply come here, and then I could update it. And then I ask it to save and redeploy. So it updates the config map on the clusters, asks the server to restart the pods, and if I reload my service now, I now have the updated version of the container. So everything is in place for the developer to be able to change config, change the service, change the version of the service, add a new service with a kubectl or the templating engine. And at the template level, we kind of simplified most of it. We try, for ease of use, we try and scale the logic of how a service is defined to be the same or as close as possible. So we created a template for an Nginx service. We created a template for a Postgres database or a Spring Boot application. So at this point, when a developer comes in and wants to create a new environment or a new service, then he simply copy-pastes that section and puts whatever values is necessary for that kind of templates, push a PR, we validate it, and then we're able to reload. So in this case, let's say here, it was in San Francisco, it was just SF, then we save the template, and in the bot, we ask it to reload the whole templating of my stack and repush it. So at this point, what it does is that it's going to fetch the new template, apply the new values to my stack, and redeploy all the services so it matches the new services that I pushed. And if we reload that part, it was service 2, supposedly. It's still starting. Okay, so it's finished starting. And reload it. And it's not working. But anyway, the demo gods are against me. But normally, it would have fetched a new value, the template would have been applied the new values, and it would have the service will have the new environment properties coming to it. Another part that we put in place is also monitoring of the cluster. Since users have full access to their stack, you want to be proactive to make sure that you don't run out of memory, don't run out of CPU. So we implemented limits and requests on every stack and every services. The idea behind it is that a single namespace can use up to a certain amount of memory. And if the cluster is out of memory, then it won't create a new stack and block everyone else. So we kind of try and validate as much as possible up to a certain point that the cluster is as healthy as possible. That's pretty much it for the demo. Yeah, so I can take any question. If anyone as some part of the logic that they want to dig deeper, either now or after the other talk. I'll be around if you have any question or intrigue on how this is. Yeah?
Why did you use traffic rather than defining your own ingress controller?
We took
the question. You repeat the question.
Why would we pick traffic for instead of defining our own in this case? To be honest, it's really a question of ease of use. Traffic is really performant. It has a lot of nice feature for whitelisting, domain name, forwarding. You can also define the path. So you have all the feature that Kubernetes offer you in Ingress Controller, plus you have additional annotation that you can add to those. You can do a CIDR, whitelisting, and a couple of other things like that. So it was really a question of looking at the feature map, what we think we might need down the line, and simply implement it. But the beauty of it is that it's just an Ingress Controller. If it doesn't do the job, I don't have anything to change on my program. I just need to remove the Ingress Controller and put whatever Ingress Controller I want, the Nginx one or an HA proxy one or whatever, and it will do exactly the same thing without changing anything in the stack itself.
Have you considered using Helm? Have you considered using service mesh to be able to segment the namespace? And have you considered custom resources as a mechanism to define these independent environments?
We looked a little bit at Helm. To be honest, I've never been a big fan of the way Helm deploys and the versioning of the templates and the way it's done. The fact that you need to deploy something on the server itself and upload your template to the server, it kind of removed a little bit of flexibility of being able to test my own templating before actually enabling it on on-demand. So the idea is that since it's driven by the on-demand process, then the process I'm running on this machine could be also running on our dev cluster, and we'd be able to test our templates.
There's ways of dealing with that, but that's right.
Yeah, for sure. As for custom resource and all of that, I'm sure there'll be a way to define those directly in the YAML to create new services and all of that. We went with the templating engine simply because we wanted also custom variable, custom resolution. The way we version packages, we coded our own in Golang to be able to resolve the NPM package version compared to whatever other version we push. So it was simply a way of having flexibility. But at this point, it's really a choice of doing your own and choosing the one you're comfortable with.
Service mesh.
Yeah, service mesh. Next step, we want to push Istio. We're using Calico for the Kubernetes side for networking. So the whole idea is to be able to define mutual encryption between our services. We want to implement ingress and egress on every service to be able to tell which service can talk to which other services. But the idea is that since the stack upgrade runs right now is not in Kubernetes, we simply wanted to push a very simple version of the stack into Kubernetes and then build from there, since we don't want to attack like everything at the same place. So it's a progressive migration towards complete Kubernetes architecture. Yeah?
How do you deal with persistent data?
We don't. That's the best way of not dealing with it. So the idea is that since it's ephemeral, the database is also ephemeral. So what we did is that we create a subset database. We boot up the stacks with that subset database, and then it only lives for the duration of the stack. So you restart a container, you lose your data. You delete your stack, you lose your data.
Are you running these clusters in AWS or just on your laptop?
It's running in AWS. So it's we're running multiple nodes in AWS with an auto-scaling group. We use cups to manage the cluster, since I mean, if anyone here has actually played with the Kubernetes on AWS, I mean, I'd love to, but it's kind of like Duke Nukem forever. It's been talked forever, but nobody actually be able to play it with it. But yeah.
How do you manage secrets?
Right now we don't, but down the line it will be mostly HashiCorp Vault that will hold the secret and dynamic secret and all of that. So we probably won't be using Kube Secret itself, or if down the line there's an integration between Vault and Kube Secret, then it's probably something that's going to be pushed into that. Yeah.
You mentioned that that these environments are leases, and then basically the lease.
Yeah, that's one part I didn't talk, but the idea is that we implement. The question was like about the lease. One of the problems that I've seen before with on-demand environment is that people create one and never use it after it. So someone wants to try something and then, oh, he kind of forgets it, so you're using like a lot of memory and for nothing. So what we did is that we implemented a very, very dumb lease system. So when you define your stack, let's say I use the command stacks, it's not implemented on this version, but we create a 7-day lease. So 24 hours before the expiration, it receives a Slack notification saying, oh, by the way, your stack will be auto-deleted in 24 hours. If you want to renew it, just tell me and I'll do another 7-day. So we just use that as a protection of people leaving behind stacks that they're not using and then blocking or costing money for the company for nothing at this point.
We'll probably have to stop there, otherwise we'll be here all night.
Yeah.
But that was really good talk.
Cool, thanks.